Hello everyone, welcome to my YouTube channel on Engineering Mathematics. In this video, I am going to talk about the concept of gradient of scalar function phi. It is also denoted by del phi. To understand gradient of phi, one has to know what is vector differentiation operator. It is called as del and is denoted by triangle pointing downwards. It is defined as I into dabba by dabba x plus j into dabba by dabba y plus k into dabba by dabba z, where I, j and k are unit vectors along x, y and z axis respectively, whereas dabba by dabba x, dabba by dabba y and dabba by dabba z are partial differential coefficients. Dabba by dabba x represents partial derivative with respect to x, dabba by dabba y represents partial derivative with respect to y, and dabba by dabba z represents partial derivative with respect to z. So this is vector differentiation operator del. Now let us see definition of gradient of phi. Here let me tell you, phi is a scalar point function. Gradient of phi is denoted by del phi notation, and it is given by I into dabba by dabba x plus j into dabba by dabba y plus k into dabba by dabba z of phi of x, y, z. When we operate this del on phi, we get I into dabba phi by dabba x plus j into dabba phi by dabba y plus k into dabba phi by dabba z. Note that we have started with scalar point function phi and now we ended with a vector point function. So grad phi converts scalar point function to vector point function. Let us see geometrical interpretation of grad phi. Gradient of phi is the normal to the surface phi of x, y, z is equal to c. That is, it is the perpendicular vector to the tangent plane at point P to the surface phi. Look at this diagram. Here, this is surface phi of x, y, z is equal to c. This is point P on this surface, and this is tangent plane to this surface at point P. Then this perpendicular vector at point P to this tangent plane is called as gradient of phi. I hope you understood this geometrical interpretation. Now we'll see some examples of gradient of phi. In this first example, we are given if phi is equal to 3x square y minus y cube z square, then we are asked to find gradient of phi at point 1, minus 2, minus 1. So let us see how to find it. First we write definition of gradient of phi. As we know, it is given by del phi. So when we operate del on phi, we have I into dabba by dabba x of phi plus j into dabba by dabba y of phi plus k into dabba by dabba z of phi. Dabba by dabba x is the partial derivative of this phi with respect to x. So to find it, we have to keep y and z variables constant. Then we will differentiate phi with respect to x. So we get 3 into 2xy minus 0. Here there is no x in it, so this is constant term and its derivative will be 0. Plus j into derivative of phi with respect to y, keeping x and z constants. So its derivative will be 3 into x square, because derivative of y is 1, minus 3y square into z square, plus k into dabba by dabba z of phi, that is partial derivative of phi with respect to z, keeping x and y constant. So clearly first term is constant, so its derivative will be 0, and derivative of minus y cube z square would be minus y cube into 2z. So gradient of phi will be I into 6xy plus j into 3x square minus 3y square z square plus k into minus 2y cube z. Now we'll find out gradient at this point 1, -2, -1. To do so, we just have to put this point in this gradient of phi. That is, we will put x is equal to 1, y is equal to -2 and z is equal to -1. So we get gradient of phi at 1, -2, -1 as -12i minus 9j minus 16k. Now let us look at second example. Here we are asked to calculate normal to the following surface f of x, y, z is equal to sin x into e raised to y into log z. As I already explained, what is normal to the surface? Normal to the surface is nothing but gradient of the surface. Here surface is denoted by f, so we have to calculate gradient of f. So let us note what is gradient of f. Gradient of f will be given by I into f by x plus j into f by y plus k into f by z. So let us first of all find out what are these partial derivatives of f. Here f is sin x e raised to y into log z. So f by x, that is partial derivative of f with respect to x keeping y and z terms constant, will be cos x into e raised to y log z. F by y, that is partial derivative of f with respect to y keeping x and z terms constant, is equal to sin x into e raised to y into log z. Because e raised to y's derivative is e raised to y, this f by y will be sin x into e raised to y into log z. Similarly, f by z, that is partial derivative of f with respect to z keeping x and y constant, will be sin x into e raised to y into derivative of log z with respect to z, that is 1 by z. Now we will substitute these partial derivatives in the definition of grad phi. We get grad phi is equal to cos x e raised to y into log z into I plus sin x e raised to y into log z into j plus sin x e raised to y into 1 by z into k. This is normal to the surface f of x, y, z is equal to sin x e raised to y log z. I hope you understood the concept of gradient of the function. Thank you guys for watching this video. Please subscribe my YouTube channel for more such engineering mathematics videos. Please press the bell icon to have updated information about my videos.